Hey guys, welcome to lesson 3.2.3 day 1. Today we're going to talk about multiplying and dividing rational expressions as well as the excluded values concept that we've already been talking about. Alright, so before we talk about multiplying and dividing rational expressions, it's a good idea to talk about multiplying and dividing just regular fractions without any x's because the rules are the same. And so it'll just be simpler and easier to talk about it with just numbers first. So hopefully you remember from elementary or middle school that when you multiply fractions, you simply multiply across. And that's why multiplication is so convenient. This doesn't work for any other fraction operations. So 1 times 6 equals 6, and 2 times 4 equals 8. So you get 6 over 8. Now, in order to simplify this, we know we can divide both the top and bottom by 2. So if you notice that you can simplify it, then definitely go ahead and simplify it. All right, so this is the unsimplified answer, and that 3/4 is the simplified answer. That is what MyOpenMath is going to want. All right, so let's try another one. We can do 3 times 6 is going to be 18, and then 4 times 15 is going to be 60. All right, and we can simplify this as well. If we were to divide both the top and bottom by 6, we would get a new simplified fraction of 3/10, right? Because 18 divided by 6 is 3, and 60 divided by 6 is 10. All right, so again, that's the non-simplified answer. This is the simplified answer. This is the one that MyOpenMath is going to want. All right, so multiplication is simple enough. Now let's go ahead and talk about division. With division, it's basically glorified multiplication, just with one little extra piece. So here's a helpful acronym that we like to use when we are dividing fractions, and what it stands for is keep, flip, change, right? And we're going to talk about what that exactly means. So if I have my example right here, 2/5 divided by 1/3, the keep means that I'm going to keep the first fraction exactly as it is, so rewrite it. And then flip means that I have to flip my second fraction. So instead of 1/3, I'm going to write 3/1. Right? And then change means that I'm going to take my division sign and I'm going to turn it into a multiplication sign. All right, so now that we have rewritten this problem to be multiplication, we can go ahead and follow our old multiplication rules, which means we can just multiply across. So 2 times 3 equals 6, 5 times 1 equals 5, and we can't simplify any further than that. So that's it for that problem. All right. Another one, we have 1/7 divided by 3/14. So let's follow the keep, flip, change rule. So we'll keep the first fraction as is. Flip the second fraction. So instead of 3/14, we have 14/3. And then change the division sign to multiplication. Right? And then you end up with 14/21. Now this is the unsimplified answer. We could divide both the top and bottom by 7. And that would give us a simplified answer of 2/3. All right, so now that we've talked about how multiplication and division works with regular fractions, let's go ahead and apply these rules to rational expressions. So this first problem is 2x minus 5 over x plus 1 times x plus 1 over x minus 1. So just like we did up top when we multiplied fractions, we're going to go ahead and just multiply the tops and the bottoms. However, do not distribute. Okay, do not distribute. We're just going to squish them together to represent the fact that they're being multiplied. All right. Once you squish them together, this turns into what we did last week with just simplifying rational expressions. We can go ahead and cancel anything that divides out into 1. So this x plus 1 and x plus 1 are the same, so we can cancel those. And then we end up with a final simplified answer of 2x minus 5 over x minus 1, because that's what's left after we crossed some stuff out or canceled them. Right, and if we were to find excluded values, which it didn't necessarily ask us to, but we're going to do it anyway, we want to use both of these bottom factors. Take each one and set it equal to 0. So when you solve those, you get x equals -1 for this factor, x equals +1 for that factor. So my excluded values, that's what EV stands for, are -1 and 1. Alright, now let's try a division problem. And we're still going to use the same rules that we just learned up top when we did division of regular fractions. So let's start with the keep, flip, change rule. So keep the first fraction as is, so 2x minus 5 over x plus 1, times, we change the division to a times, and then we flip the second fraction. It's always going to be the second one that you flip. Alright, so now we have a multiplication problem, and so you can rewrite it to just be all squished together. Now, you don't have to necessarily rewrite it at this point. You can just cross stuff off from this stage, but I'm just going to do that here to make sure that nobody is confused. But eventually I'll start doing it the short way. Alright, now we are ready to cancel stuff. These x plus 1s, we can say goodbye to them. And that's going to leave us with 2x minus 5 over 2x plus 5 for our simplified answer. Alright, and now for excluded values. Now remember what I told you guys. It's very, very important that you do not use the original when you're working with division. Okay, you always want to use the multiplication version. So we're going to use these two, right? Because we had to flip the second fraction, which is going to change what's on the bottom. And the bottom stuff is always what we use for excluded values. So here we have one. If we solve that, we get x equals -1. This one we need to do a little bit more work. So let's go ahead and start solving for x. Subtract 5 from both sides. We get 2x equals -5. Divide both sides by 2, and you get x equals -5 over 2. So basically, the excluded values are -1 and -5 over 2. It's completely normal to get fractional excluded values. Alright, let's go on to the next page. We have a couple more examples, 4 to be exact. So for this first one, I'm going to go ahead and not bother rewriting them with the squished way if it's multiplication at this point. So here, and you know what, I can actually go ahead and zoom in a little bit. Oh yes. Alright, so here, if it's multiplication, we can just turn it into one big giant fraction and say that, okay, well, what can I cancel? Remember that these all have their own imaginary parentheses. So we see that there is an x minus 5 on the top and the bottom, so we can cancel that. And we end up with 4x plus 3 over x plus 3 left over. Okay, and remember, you can only squish them together like this when it's multiplication. Let's go ahead and find the excluded values. So for excluded values, we need to use both of these. Even though we crossed one out, notice I'm still using both of them for excluded values. So x minus 5 equals 0, x plus 3 equals 0. So we get 5 and we get -3. That tells us that the excluded values are 5 and -3. Alright, on to the next example. This is a division example, so let's go ahead and start with our keep, change, flip process. So x plus 2 over 9x minus 1, we're keeping the first fraction as is. We're flipping the second one. So now it's going to be 9x minus 1 over 2x plus 1. And we change division to multiplication. So now, we know that when we're multiplying, it really pretty much is just one big old fraction. So we can cancel these 9x minus 1s, and that ends us up with x plus 2. Oh my goodness, I got a really fat marker here. All right, x plus 2 over 2x minus 1. Okay, and for excluded values, again, I'm going to say this till I'm like blue in the face. Do not use the original problem when you're doing division. You have to use the multiplication version to know what's supposed to be on the bottom. So let's go ahead and set each of these equal to 0. We have 9x minus 1 equals 0. And we have 2x plus 1 equals 0. Right? We're going to have to do a little bit of work on each of these in terms of solving for x, but this is just some basic algebra that I know y'all can handle. All right, added 1 to both sides, and now we're going to divide by 9. I'm not like taking too much time to explain what I'm doing here because you guys should know what I'm doing here if you all have been through Algebra 1. Right, so we get 1/9 here, and then here, let's go ahead and solve for x again. Subtract 1 from both sides, 2x equals -1. Divide both sides by 2, and x equals -1/2. So I will say that my excluded values are 1/9 and -1/2. All right, let's move on. Here we have another multiplication example, so let's do it. Remember, with multiplication, these are really just like one big giant fraction, so we can start to see what cancels. Give everybody their own little parentheses. So here's an interesting example. At first, you might look at this and be like, well, shoot, nothing cancels, nothing's the same. But upon further investigation, you notice that this is a 2m plus 3, and this is a 3 plus 2m. And you guys probably know by now that addition is commutative. 2m plus 3 is the same thing as 3 plus 2m. It doesn't matter what order you use when you're doing addition. So these two are the same, and therefore they cancel. And that tells us that our final simplified answer is 7 plus 4m over 3m minus 2. All right, on to the excluded values. We have this one and this one. So 3m minus 2 equals 0. Let's solve this. Get m by itself. Add 2 to both sides, so we get 3m equals 2. Divide both sides by 3, and we get that m equals 2/3. So that's one excluded value. Let's do the other one with the 3 plus 2m. So 3 plus 2m equals 0. Now we can go ahead and subtract 3 from both sides. So we get 2m equals -3. Divide both sides by 2. And we end up with m equals -3 over 2. So our excluded values are 2/3 and -3 over 2. All right, one last example. This is going to be a division example. One thing I need you guys to notice right off the bat is that this thing is squared at the bottom. So let's make sure we acknowledge the fact that there are 2 of them. So let's go ahead and rewrite this with the keep, change, flip method. Now the first one we have to keep, right? We know that that's what the k stands for. So 5x minus 2, 3x plus 1. I am keeping it the same, but instead of writing it that it's squared, I'm going to write 2 of them because that's going to make my life easier when I'm going to cancel stuff. Right? Turn it into multiplication and flip the second fraction. Ooh, big line. All right, that's a 5. So now, again, because it's multiplication, I can just say that it's one big giant fraction. And let's see what cancels. We have a 2x minus 3 that cancels. We have 5x minus 2 that cancels. And we also have an x minus 4 that cancels. Lots of stuff. So 3x plus 1, oh my gosh, such a fat marker. 2x minus 3. This is our final simplified answer. And then our excluded values, I'm running out of recording time, so I'm going to pause the recording. All right, I've set all of these equal to 0 and solved. These are the same because they're the same fact.